Hello, my name is John Novitsky. I'm CEO and co-founder of Agriculture Resource Management, Inc., with the DBA as Aquaponics. I want to thank the organizers of the Asilomar Microcomputer Workshop for inviting me to speak today. The title of the talk is A Novel Approach to Combating Global Warming. Really, it's how Silicon Valley is partnering with the farmers in the California Central Valley to develop a new business model which fundamentally makes more money for the farmers while providing environmental benefits for free. One of the biggest challenges that the world faces today is combating global warming, which is producing rising sea levels, extreme weather, meaning droughts and floods, which are in turn producing population dislocation, and it's also increasing pressure on the wild fisheries. Now, one approach with a solution to this is to partner with the farmers to help solve the problems. This is fundamentally what's happening is the soil contains 5 times more carbon than all of the plants growing on the soil. Our approach to working with the farmers is to co-locate an indoor shrimp farm at the agricultural site. At that site, we'll consume the agricultural waste, which is normally burned or combusted, and we'll use it as renewable biomass. This eliminates the transportation costs of input fuels, and it also eliminates transportation costs of the outputs, as long as they're used at that farm. Now, this is the distributed system, which can be scaled anywhere in the world to the size of that farm, as well as to the size of the local markets. We use pyrolysis, we don't use combustion. This produces the electricity and heat to run the indoor shrimp farm, and we capture the carbon in a form called biochar, which is then used in 2 ways at that farm. We mix it with the solid waste of the shrimp farm to produce an organic soil amendment that will be used at that farm. The outputs from the shrimp waste are very high in NPK, which are the fundamental chemicals that are used in the fertilizers at that farm. And this provides direct carbon sequestration with a half-life of something in the neighborhood between 400 and 1,000 years. Every year we do this. We also take the biochar and we feed it to the cows, which in turn halves the methane emissions from the cows. The only thing leaving the farm are the shrimp. Now, why did we pick shrimp? Well, simply put, it's the largest seafood market in the whole world. And here in the United States, we import last year 822,000 tons. 92% are frozen, and nearly all of them are contaminated and unsustainable. When we bring up our shrimp farms, they're really in a paired model. We can put an urban shrimp farm basically in any old warehouse in any old city pretty much in the world. Along with that, we will build a shrimp farm out at an agricultural site within a few hours' drive of the urban shrimp farm. And then once a week, what we'll be doing is harvesting the shrimp that are grown out at the agricultural site and driving them into the city, where the urban shrimp farm will serve as the distribution point for the shrimp where the people are. Then on the backhaul from the urban shrimp farm, we will bring the biofloc, which is the solid wastes that are produced by the shrimp farm itself, and we'll haul those back out to the integrated site out at a farm, where it'll then be converted into the soil amendment that goes right down into the soil. By doing this, we're zero waste at both sites, and we're going to be sequestering something in the neighborhood of between 18,000 to 20,000 tons of carbon per year when we use these pairs this way. Now let me have you hear from our first site where we're bringing this up in the California Central Valley with a 7th generation family farm.
Hello, my name is Sean Kelly. I'm a 7th generation farmer and direct descendant of James J. Stevenson. Our operation is located in Stevenson, California, in the heart of the Central Valley. My family's been farming this land since 1852. Our land sits directly at the confluence of the Merced and San Joaquin rivers. Our operation consists of 10,000 plus acres. We have roughly 2,000 acres of almonds, over 1,800 acres of corn, and 750 acres of alfalfa. The rest of our operation is made up of native ground or irrigated pasture. We also have some 6,000 dairy cows. We have over 3,000 milking cows, and we do all of our own heifer replacements, doubling our number to over 6,000 animals. We also have over 600 cow-calf pairs of Black Angus animals that we run on native ground or irrigated pasture. As nearly all farmers do, we strive to be great stewards of the land. I first met John and was introduced to agriculture resources management about 2 years ago. We've been working closely together over that time. I am personally an investor in Agriculture Resource Management, Inc. I also serve on their technical board of advisors. I think they have some very interesting ideas. My farm will be the experimental site to prove out their ideas. Here's what we expect. First, we will nearly eliminate our air pollution. Instead of burning our ag waste, we will use the ag waste as an input fuel in pyrolysis, capturing the carbon. Second, the heat and electricity generated will be used to supply their indoor shrimp farm. If there's any leftover electricity, we will use it on our dairy operation. Third, we'll then feed the biochar to our cows. The math looks good on paper. We should be able to vastly reduce the methane emissions of our cows. And fourth, we will also compost the biochar with the biofloc coming out of the shrimp farms and use this as an organic soil amendment in our almond orchards. If this all works as we plan, our farm will make more profit. Additionally, the environmental benefits will happen for free. We will not need any government subsidies. These will include air pollution nearly being eliminated from our operation, water pollution vastly reduced, irrigation water reduced by 20%, crop yields potentially going up, milk and meat yields potentially going up. The only item leaving the farm are the shrimp. And ARM has buyers for all the clean shrimp that they can make. The renewable biomass for input fuel is produced here annually. The consumption of the soil amendment and of the cattle feed additive is consumed here annually. I really like their business model and the manner in which ARM has partnered with us. They are not dictating any terms. Rather, we are discussing problems and coming up with a solution that fits for both parties. If this works at my farm, we can scale this approach worldwide. Farmers will be a critical part of how we bend down the curve of global warming, starting with James J. Stevenson's ranch here in Stevenson, California. Follow our progress at www.aquapronics.com. Here's a scale model of the shrimp farm to be built at James J. Stevenson's ranch. The big buildings are the indoor shrimp farms. The tractors with our ag waste come in here, dump the waste in the back. That's where the energy will be produced, as well as the soil amendment and the cattle feed additive.
So here's the status and then the plans over the next few years. First, our pilot line for the indoor shrimp production is in production. We're doing harvests right now about 2 or 3 times a month, and that'll go up to having something in the neighborhood of 8 harvests per month sometime late this summer. It's in rural Montana, and we still have some incremental improvements as we continue to build these things out and make the harvest. Then the next step for us is to take that fundamental building block of the indoor shrimp farm, and instead of heating the water using electricity, we'll be heating the water in the shrimp tanks using the output water from the pyrolysis system. Now, what this is, there's typically the pyrolysis system is boiling water to push a steam turbine to create electricity, and this will be the hot water on the downhill side of that electrical turbine, roughly coming out at 194 degrees Fahrenheit. So we'll need to have a heat exchanger to bring it down in temperature, and we'll have to develop the plumbing that'll be monitoring the temperature inside the shrimp tanks and turning the pumps on and off and that sort of thing. We'll be using no change to what's happening inside the tank for the shrimp water, but what will change is the floor. And the floor is going to be built out of a material called warm board, which has in it the pipes where we can just hook up the hot water and circulate it under the floor to maintain the tank temperatures for the shrimp farm. We've already identified the site where we'll be doing this. They already have all the input biofuels. They already have all the permits they need for their waste management, and it's the cleanest such burning facility in the world. And that's why we're working with them. That starts next year. Now, once we have it all done and debugged, that's when we bring it back to Sean Kelly's farm at JJ's Ranch here in the Central Valley of California. And at that point, the only change we'll be doing is at the lead vehicle site, we're using forest waste as the renewable biomass. At Sean's, JJ's Ranch, we'll be using the waste from the almond orchard, so the dead trees, the tree trimmings, and the almond shells as the input fuels to produce our electricity and our heat. And then that stuff goes right back into the farm right there. And we should be starting at JJ's Ranch sometime late next year or early in 2023. Now, the beauty of all of what we're describing, it scales around the world. I was in Vietnam about a year and a half ago, and we've already identified that we could do something in the neighborhood of 200 such sites in the rice paddies in Vietnam. We could do something in the neighborhood of 400 at the coffee plantations in Vietnam. And here in the California Central Valley, we have 1,650,000 acres of nut orchards. And if we did each one at 1,500 acres per such integrated site, we could build up to 1,000 of these indoor shrimp farms just in the California Central Valley alone. And that would represent a little bit less than 8% of the annual imports of shrimp into the United States. So we're a long way from saturating the market, even if we did 1,000 of these things in the California Central Valley alone. Okay, and with that, I'll be open to any questions. Thank you.